Hey, DDTHJ here, and welcome to RLBot Start-To-Finish, Episode 5. In this episode, we're going to be covering how to make our own states for Gosling, how we plan them out and develop them. We'll also be looking at improvements that I made to Gosling since the last episode. Hey guys, welcome back to the series. We're going to go ahead and jump right in and show you a match between Gosling and an all-star that's currently named RLBot because I can't change the name. I'm going to take cuts out of this as well as cuts out of maybe some different matches and just show you what's new with Gosling. What you'll notice is that first off, he has rendering now, so he's drawing lines and stuff all over the screen. I'll explain what they mean. And he has a new state, which is if he can't get to the ball, he'll go and grab boost, and specifically boost that's closest to where the ball is. So that's what we're going to be covering today. I'm not going to do any live programming. It's mostly going to be explaining my changes. We also do some stuff with pre-processing and planning out the future, because the next episode is going to be about the future. So let's jump right into some code. I'm going to go ahead and cover the pre-processing changes first because they're the easiest. From feedback that I've gotten, a lot of you guys have wanted a better pre-processing that handles opponents, because right now Gosling only knows about himself and the ball. And so what I've done is I've added in additional code for grabbing and creating objects for both opponents and teammates. And it'll keep all of them in a list in self.players. Another thing that I've done, you'll notice this is much shorter code than before. And the reason is because I've made temporary variables, one called car, one called ball. And it just contains game.gameCars self.index. And that way it just shortens the length of these, nothing else has changed. Down in here, we go through the range of game.numCars. And it's just the same thing. We're using this I variable as an index, and we're going through all the different cars. We're creating temp objects for them, and it updates the current object. Otherwise, it'll add it as a new object if the game has just started. So in this manner, you can keep track of, what's slightly different is instead of just an object, it's got a couple different attributes that normal objects don't have. These have a team and an index. The index isn't too important, but the team will let you know. You can compare that to your own team to see if they're friendly or an opponent. And the reason that these changes to pre-processing are important is because in the future, if anyone has a Gosling-based bot, let's say they have some state and a controller, and they want to share their bot with somebody, you have to expect that they're going to have the same pre-processing information that you do, because remember, our states take the entire agent as a parameter. And a part of the agent is how it handles the pre-processing. So if you want to make your states and controllers really easy to send between people, or if you're somebody who wants to be able to receive states and controllers from other people, if we all follow the same pre-processing, then we can all send them back and forth with no issue. So that's the change to that. I also have a new thing up here for a state called wait. And that's all that's up there. Other than that, I believe this file hasn't changed. Let's get into the new version of CalcShot. Okay, so we're back with CalcShot, revisiting this because I've made it a lot better. If you haven't already, I recommend watching the RLBot 10-minute montage. I created a bot for a small competition. It wasn't an official tournament, but it was still a lot of fun, where we had to make a bot in 3 hours, and I spent pretty much all of the 3 hours working on a very similar CalcShot state. And afterwards, it was actually better than Gosling's, so I've updated it to fit into Gosling. I've taken the poor programming habits of me making it in 3 hours out of it, and now it is this. I'll make it a little bit larger so we can fit some more lines on the screen here. I understand you guys do have to have it in HD in order to see all this stuff. So, what's changed? Well, to be honest, it's probably so different now that I don't even remember what the original looked like. So we have well, still using Calc controller, so I guess that hasn't changed. We're defining a left post, a right post, and a center. I don't believe, well, prior to this, we just worked off of a center. I know that. Gosling used to always shoot towards the center of the goal. We also have a time guess in here, but we can ignore this. Right now we have it set to 0 seconds. This has to do with future stuff that we're not going to get to quite yet. Now what we're doing is we're getting a whole bunch of vectors here. Vectors from the left post to the ball, from the right post to the ball, from the left post to the agent, from the right post to the agent. And we're seeing is if we drew a line from the center of the goal, is our car to the left or the right of that line. This will do a brief explanation of what's going on here. So here's our goal. And we've got a ball, and we've got our car. So right now what we're doing is we are drawing a line from the goalpost through the ball, from either goalpost through the ball, and it's making a cone. Now, if our car is inside of this cone, we can actually just go straight for the ball. And if we hit the ball while we're inside of this cone, it's just like, well, it's not just like Gosling, but the ball will go into the goal. If the car is to the left or the right of this cone, the most efficient route to hit the ball will be along one of these post lines. So instead of Gosling, who chooses a line from the center of the goal, see how I'm going to declutter this a little bit. So Gosling is like this. Our new bot would look at just the left post line. And you'll see that if we wanted to do the Gosling method, we would have to come way farther out in order to line up for this shot. And ultimately, that's going to just hurt us overall because the ball could have moved out of the way by then. So instead, we're aiming for this left post line. So overall, it's just a much more efficient shot. And what this also means is that if the ball is really close to the goal, like if it's right here, we're going to have a really wide cone. So our car isn't going to be worried about lining up for some goal shot that's like way out here. It's just going to hit the ball in. So you're going to get out of those awkward spots where Gosling is just undecided as to, well, maybe the ball is right in front of the goal and trying to roll in, and your bot is just swinging around wide trying to figure out how to line up a shot when all it has to do is touch the ball. That's what this is designed to fix. So in this case, if we are too far to the left of the goal, then we use the right post line. If we're too far to the right of the goal, we use the left post line. Otherwise, our goal target becomes none, in which case the line that we follow is actually the line from the ball to the agent, so Gosling is always directly on that line. More correction happens depending on the ball velocity. I'm not going to get terribly deep into this. The important thing is that concept that I showed in Flash, where we're changing our target based on where the car is, so we have the most optimal shot, or the most efficient shot. I think everything down here is the same. I might have changed how the speed is handled. The speed function is tricky. I'm going to continue modifying it in the future because right now it is still not perfect. Down here we get into some rendering. What happens is, based on the speed, the color of the line coming out of the ball changes. So it'll actually tell you how fast Gosling thinks he needs to be going. But down here, we're drawing lines. One line from the post to the ball, which gives us a kind of an opposite cone. The third one you can see here, it's from the ball location to the target location. And that just shows you where Gosling's planning to drive. And you saw that in the video. As that got closer to the ball, as Gosling got closer to the ball. I've also changed how this state terminates itself. That's not the main focus of this episode. If you have questions, you can just ping me in Discord or put a comment in the comments below. What I'm going to get into next is creating states on your own. So I've gotten a lot of questions. How do I make a state? Or how do I make a good bot? Okay, so here's our problem. I want to make a good bot. Well, okay, fair enough. Let's make a good bot. What does it take to make a good bot? What is a good bot? we might want to update this and say we might want to update that. What if we had a bot that can play good offense and good defense? I suppose that's a improvement over a good bot, but now we have to define what is good offense and what is good defense. Now, in our case, we've tackled good offense by saying, we want a behavior that can accurately take shots on goal. So maybe we can say that. Of course, this isn't really enough to cover exactly what we're doing calc shot, so maybe I should update this a little bit more. Okay, so I have this more fleshed out. We want a good bot that can play offense and defense. So let's define offense. In offense, it should take calculated shots on goal by drawing a line from a target inside the goal through the ball and following that line. Okay, but what's the target? And what's the target, when we say drive, or when we say it's following that line, how fast is it going? How does it get to the line? Well, I explained some of this. Its speed should reflect how off target it is from the line. And then I just define what the target is. The target should be placed in the goal so the car only has to make minimal adjustment to get onto the line. I could go on to say that the target will be on a line that's between the left and right post, and its position reflects, whatever function I chose to move it. So we're breaking this down into smaller and smaller things. And of course, calcshot doesn't work all the time, and that's where I have quickshot defined. In the case where calcshot isn't possible, the car will drive towards the ball and dodge towards the goal when it's close to the ball. Of course, there's a lot of issues with that, and then also play defense. The reason that quickshot doesn't work very well right now is because it's the only state that exists it's only offensive state that exists other than calcshot. Right now, the bot will be in a position where it needs a defensive behavior, so calcshot isn't possible, and it'll default to quickshot, which is just really not ideal because the ball, Gosling will just chase after the ball and then dodge towards the goal, sometimes not even hitting the ball, and it's kind of ugly to watch. It's not necessarily the state is bad. The state is pretty bad, but it's the fact that it's being used in the wrong application. So in order to finish this, we need to add more state. Specifically, well, we'll get to defense because we haven't defined that too well yet. But specifically, let's think about, this issue where some of these states aren't possible all the time. Both calcshot and quickshot do not happen if the ball is up in the air. If I go into state and we go to available, I did change quickshot so that it doesn't happen anymore. But in calcshot, ball ready has to be true. And ball ready says that if the ball is a certain height above the ground or if it's moving vertically too quickly, then you can't go for the shot. So we arrive at cases where sometimes a calc shot or a quick shot isn't possible because we can't get to the ball, but we still want to be on offense, or we still want to be doing something. Let's hit two birds with one stone. When we can't do anything else, let's grab boost and get in a good position to address the situation in the future. So we'll have boost to execute whatever state is going to come next, and we'll be in a position to hit the ball. Well, grabbing boost is somewhat straightforward. We might have to define a little bit about what we want to do for that. Getting into a good future position, that is the tricky part. So we have a catch-all really for when calcshot and quickshot fail us. We want to be able to get boost so that calcshot and quickshot have boost to work with once we get back into them. And we want to have a good position in the future so that once we activate calcshot or quickshot, we can quickly get to the ball and do whatever we need to do. So this is a good state idea for, just adding on to Gosling and filling in gaps where he makes a fool of himself since we don't have any states to handle the current situation. Albeit it's a smaller state compared to what you guys are probably hoping for me to work on. And don't worry, that'll be in the future. I'm planning on it. But it's simple. It's, when people ask me, how do I make a state? This is what you do. You realize, a situation that requires a state. In this case, we need a state just because there's nothing better for us to do while we're waiting for the ball to come down and land and settle. And, you know, we also need to get boost and get ready for the 2 states that we're actually good at. So here's our state idea. We're going to keep defining it more and more until, you know, we have something that it's specifically like, given where the ball is, we know exactly what the car should be doing. So this is how I define it even more. Instead of just saying grab boost, we're going to go and get into a good position. We're going to calculate our position based on where the ball is going to be in the future. So we're going to look, you know, some time ahead and see where the ball is going. And then we're going to compare the coordinates of all the boost pads, all the large boost pads, to where the ball is. And we're going to pick the pad that's closest to the ball's future position. And of course, as we're going towards the boost pad, we don't want to waste any boost, so let's not spend any as we travel over there. And now we have pretty much everything we need to create that state. We know we have a target speed, or at least how we want to approach the target. We don't want to spend any boost, and we know exactly where the target's going to be. It's going to be one of the large boost pads. So let me show you what this looks like realized. Here is the wait state. It's very small. Again, it's a smaller state, but it fills a big part of what we need to be doing. Available is the only thing that requires is that time z is greater than 1.5. Time z, I believe, is something that I introduced on the 3RBot stream. All it is the time it'll take for the ball to hit the ground. I'll go explain a couple bits of that math once we're done here. So if the ball has 1.5 seconds before it's able to hit the ground, then this state will work. So what are we doing? The ball future, we have a rough guesstimation of where the ball will be in the future based on the time it'll take to hit the ground and its current velocities and everything. Once again, I'll go into that math. If we don't have much boost, then we're going to figure out, you know, which boost pad is the closest. Otherwise, we'll just target where the ball is going to land in the future. So if we are low on boost, if we have less than 35 boost, we're going to go through a list of the boost pad coordinates and compare them all and figure out which one's closest. And that'll become our target. And our target speed will be 2300, but again, we don't want to spend boost getting there. So we've made a controller to cover for that. Of course, otherwise, if we do have boost, then we'll just go towards where we think the ball will land in the future. Yeah, this is just so that as we approach the ball, we go slower. That's all that's going on. If the ball is available for calc shot or quick shot, then we expire, and we run this through Frugal Controller. So, Frugal Controller is just the same as all the other ones. Target, the steering is all the same. The only thing that's different is how we handle speed. We don't boost. If our current speed is less than the speed we want to go at, we do full throttle, but we do not boost. Instead, if our current speed is less than what we want to be going and we have the time and means to do it, we dodge. And that's it. Very simple state, and it knocks out 2 birds with 1 stone. Now let's go look at a little bit of the math. Alright, so I'm inside of Util. You can see I have the boost pads mapped out. If you're wondering how I got these, it's in the wiki. There's a page of useful game values in the RLBot wiki on GitHub. There actually are quite a few changes I made in this file, so I'm going to just pick through them as I see them. One of the big ones is I fixed the normalization function. I apologize for having it wrong this whole time. It was wrong. It was wrong, but it worked. But this is what it should look like, and it does pretty much the same thing. Just this time we're dividing by the magnitude of the vector instead of the largest component of the vector. This is the quadratic formula. All it does is find the roots of a quadratic function, and time z takes advantage of that to figure out how long it'll be before the ball touches the ground, because the ball is following a parabolic arc, which is you can express that with a quadratic. So we find the roots of that, which is what time it'll hit the ground. Pretty straightforward stuff. future, it just takes the x, y, and z of the ball, adds them to the ball velocity times the time. Distance equals rate times time, and returns that. So it doesn't account for the walls or anything. It just kind of guesses where's the ball going to be in the future. Very rough. DPP, I explained, was the second derivative of our distance to the ball, and it looks like this. I'm not going to go into details. I'm not going to go into the math behind it, but all you need to know is that you can get the relative velocity between two objects if you feed them into this. These are all the same from what I remember. So that is that. Not too many changes, but I do believe I answered some critical questions for bot development. Some key things I want you guys to know of is that if you do plan to stick with a Gaussian base, I highly recommend that we all have the same pre-processing, because then it's a simple drag and drop to get a controller or a state working between different bots. As long as the pre-processing is the same, everything else will work the same. Hopefully we can kind of make a database of Gaussian states. That'd be pretty cool that we could share with each other. Now, let's talk about next episode, because that is going to be the exciting one. That's where we're going to get into aerials and all of the fun stuff. In the next episode, we are going to really look at upper level play. Right now, everything Gosling does is reactive. All his states look at a situation and they react to it. What we want to ease into is states that are proactive, that can take a situation and act upon it. What this means is we're going to be planning actions into the future with our states, being able to take aerials, better calc shots, much higher level play. We'll be looking at Paul, which a lot of you have not seen before. It's the bot showcased at the end of the intro, the amazing intro. Paul actually has a specific branch of him where he plans shots into the future. So we're going to be looking briefly at Paul and learning from him and applying that to Gosling. We're going to get Gosling up to the next level here. So I hope you guys are excited. I sure am. Thank you guys for watching. I'll see you in the next one.